Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.39. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always zero. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.39. Find voltage VAB in given below figure. This is the circuit diagram of given problem. We have to find voltage between these 2 points labeled as VAB, and label VAB is indicating that point A would be on higher potential than point B. Because this is a closed loop circuit, so we will use Kirchoff's voltage law for the solution of this problem. Before using Kirchoff's voltage law, first we have to assume the direction of current inside this circuit. I am assuming current I is flowing inside this circuit in clockwise direction. You may take counterclockwise as well. It totally depends upon your own choice. Now make polarity notation across resistive elements in a closed loop according to the assumed direction of current. We are using passive sign convention theory. According to this theory, current entering terminals are taken with positive sign while current leaving terminals are taken with negative sign. So our resistance current entering terminals will be taken with positive sign and current leaving terminals will be taken with negative sign. For this 4 ohm resistance, current entering terminal is positive and current leaving terminal is negative as well. Now write KVL equation for this closed loop circuit. Start from here. Voltage across this 4 ohm resistance will be taken with positive sign because current entering terminal is positive. So voltage across this 4 ohm resistance, that is the product of current through it and the value of resistance I multiplied by 4, will be taken with positive sign. Move to next element. Current entering terminal is positive, so 9 volt will be taken with positive sign. Move to next resistive element. Current entering terminal is positive, so voltage across this 6 ohm resistance, that is the product of current through it and the value of resistance, will be taken with positive sign. Same case will be here with 3 ohm resistance. Product of 3 and I will be taken with positive sign. Move to next element. Current entering terminal is positive, so 6 volt will be taken with positive sign. And the last element of the circuit, that is 2 ohm resistance, and product of 2 ohm and I will be taken with positive sign because current entering terminal is positive. Now solve this equation. The equation will form 4i, 6i, 3i, 2i plus 9 and plus 6. Now add all these values that include variable I inside them and add 9 and 6 together. The equation will become 15i plus 15. Now place 15 on the other hand side of equal. The equation will become 15i equal to minus 15. Divide on both sides with 15. The value of current I will become minus 1 ampere. But we will further solve this scenario according to our assumed direction. Now we are interested to calculate voltage across this 4 ohm resistance that is labeled as VAB. We know the value of current that is flowing through this series circuit, so we can calculate voltage across this 4 ohm resistance using Ohm's law. The value of VAB will be the product of current through this resistance and the value of resistance. Here current is taken with positive sign because current is entering from positive terminal of this resistance. Now replace I with its value that we have calculated in previous step. The value of I is minus 1 ampere. The product of minus 1 and 4 will become minus 4 volt. So the value of VAB is minus 4 volt inside this circuit. This was exercise problem number 2.39. Thank you. See you again in next video.